Hello, today I am going to create a program that solves the number pad module from the game Keep Talking and Nobody Explodes. We see a multicolored number pad with clear and enter buttons at the bottom. The goal of this module is to submit the correct code. We find this code by looking at the manual. Each digit is separated by their own level. Each level has a set of conditions that are either true or false. We must find the first set of true conditions and follow the directions from there. Before we start, I want to go over the wheel on the second page of the manual. This module will ask us to take numbered paths. We start in the center of the circle. If we put a line between the 8 and the 2 and go clockwise, 2 would be the first path, 5 would be the second path, 7 would be the third, and 8 would be the fourth. Let's say we got path 1, and 2 is our current first digit. You can see that there is another subsection of numbers. We do the same thing with 2 being first, 3 being second, etc. Just remember to always go clockwise and you should be fine. Looking at level 1, the first true condition is the serial number containing a vowel. We are told to take the third path, which is 7. Going back to the first page of the manual, the first true condition in level 2 is there are at least 2 blue numbered buttons and at least 3 green buttons. We take the first path, which gives us a 4. On to level 3, we take the second path which makes our third number 8. Our code so far is 748, but since our condition tells us to reverse the code, it's now 847. For level 4, we have one yellow button, so we take the first path, which is a 0. Our code is now 8470, but we have to add 1 to each digit, so it's now 9581. We have to look at the final instructions in order to figure out if our code needs to be changed. We can skip the first 2 conditions since our last digit of the serial number is a 9 and we have 2 batteries. The third condition tells us to swap the first and fourth digit, which makes our code 1589. The sum of the digits is 19, so we don't have to reverse it, making our final code 1589. Next we take path 1, then path 2 twice, making our code 234. Reversing it gives us 432. We add 6 to the end, making our code 4326. We're always going to have the first 2 conditions be not true for this bomb since it's related to edge work, so we're always going to be swapping the first and fourth digits. Our code becomes 6324. The sum of the digits is 15, which is odd, so we don't have to reverse it. I would go over this example, but it gives us the same answer as the first one since it meets the same conditions. So our number is 1589. Again, this is the same as example 2. We get 6324 for the code. Lastly, we take paths 3, 2, and 2, making our code 775. We reverse it to get 577. The last digit is 8. We add 1 to each digit to get 6889. We swap the first and last digit to get 9886.
So long, Bowser!
I wanted the GUI to speak for itself, so I didn't have to tell the user how to put their input in. I decided to use buttons to recreate how the module looks. I then had them cycle through colors every time it's clicked. For the solver, I started with creating 4 ints that represent each digit for the code and used the color enum to represent each button on the module. I then created a method that would tell me how many buttons were a certain color, since that information is used a lot. In order to represent the wheel, I decided to make a tree. I talked about trees before in the poker video, but I'll explain again since they won't be the exact same. For those who don't know, a tree is a data structure that forms a hierarchical path. The data the tree holds is what's called a node. Nodes can represent a lot of things, but for this example, it's going to represent the numbers on the wheel. Nodes can also be linked to other nodes. The node that is being linked is what is called a child, and the first hierarchical node of that child is called the parent. We have a starting node, which is called the root. Each node can have an infinite amount of children. In poker, I only needed at most 2 child nodes for each parent. That data structure is called a binary tree. For this module, each node will either have 0, 4, or 2 children. Let's take path 1 for example. The root will be 2, and their children would be 2, 4, 9, and 0. Those children will have children, and the cycle continues until we reach the outer ring. Since there are 4 possible starting points, there will be 4 trees with each one having their own children. I decided to have the children be a list since the number of them vary. We'll know which child to go to next based on the conditions the manual tells us. Every time we go to a new node, we will get the number inside that node and add it to our code. After the initial code was found, I checked for any adjustments that needed to be done to it. I then combined the numbers and showed it to the user. Let's see a demonstration.
It's me, Mario!
Thank you for watching the video.